Welcome. In this video we're going to be going over how to solve this particular problem. What is the limit of this function as x approaches negative infinity? Now the first step is to recognize that this is actually over the denominator of 1. So another thing we can do is use the difference of squares to actually move this function further along. So we're going to be multiplying the top and the bottom by this. And if you remember the difference of squares, you would have this multiply, or rather subtract some number. And for the other one, it's going to be the opposite of that, the addition. And well, let me just write it out. So a squared subtract b squared equals, or it can be written as a subtract b multiply a add b. That's the logic we're using right here. Because this, we have something subtract something, multiply something, add something. And the whole reason we're doing this is because we want to get rid of the square root, at least in the numerator. Now if we multiplied the top ones of the numerator together and canceled out whatever we would get as a result, it should end up like being this. And 1 multiply this is just going to be this. Now this can be further simplified. Notice that we have a 2x squared and a negative x squared. That is just going to give us x squared plus 1. So we have x squared plus 1 as the numerator. And the bottom can actually be manipulated a bit further. So for this step, what we're going to be doing is factoring out an x squared from this term right here. So we're going to have x squared multiply 2, which would give you your 2x squared, and then we're going to have add then 1 over x squared, because if we were to multiply this out, this would just give you 1 again, which is equivalent to this. So everything's still staying the same, we're just rewriting it in a different form, and we still have our plus x on this side. Just extend that line a bit, and of course it's all of this here is being square rooted. Let me change colors for that. Here we go. It's still being square rooted. And actually, since we're doing this down here, we might as well do it to the top as well. The top can be simplified. Let me just erase x squared plus 1. And we're going to be changing that to, I should also erase this arrow here, just to not mislead you. We can have x multiply x in order to get the x squared. And then we can have add 1 over x. Because if we were to multiply that out, notice we would still get 1, which is the same thing as x squared plus 1. So all of this is still equivalent to this one over here. Now I'm just going to erase the top so I can make more room to work with, and I'm going to erase this part too. So now the next thing we're going to be doing is actually factoring out an x from the bottom, so that we can cancel it out with the 1 right here on the numerator. Now what we're going to be doing is having a negative x on the outside because it's going to be square rooted, and because x is, notice that it's approaching negative infinity, x is always going to be a negative number, essentially, is the logic here. That's why when we take the x out of the square root, it's going to be a negative x, not a positive one. So we're going to be having negative x multiply the square root of, and we're going to be having the 2 in here as well with the 1 over x squared. And of course we have the x over here. Now all of that is in the denominator. The top is still going to look the same as x multiply x plus and 1 over x. So notice that we can now factor out the x from the bottom. And if we were to do that, it would actually look like negative x. Let me put an equal sign here. Actually, let me change colors again. Yeah, that's good enough. So if we factor out a negative x from the bottom, it's going to look like this. And we're going to be having a negative 1 over here. And of course, we still have this portion right here. However, now what we can do is cancel out the x. So we cancel out this one and the bottom. Now, notice that since we're dealing with a limit of x approaching some infinity, either positive or negative infinity, because it's 1 over essentially, because we're going to be plugging in infinity into the x value, it's basically 1 over infinity. And that's always going to be approaching 0. So we just say this value is equal to 0. Now this is equivalent, this 1 over infinity, to saying 1 over x, at least when you're dealing with this kind of problem, this kind of limits problem. So looking at our problem, where do we see where that could possibly equal 0? Well, that happens twice in our problem, right here, 1 over x, and at the bottom here, 1 over x squared. Both of those are going to get so close to 0 that it's practically 0. And that's what we're going to be saying for this in order to answer this question. So rewriting this problem, we can do x plus, and this is going to be equal to 0, remember? So x plus 0 divided by negative square root, and we're going to have just 2 add 0 at the bottom, and then subtract 1. Or since we just zeros don't matter, we can just cross those out, and we just have x over negative square root 2 subtract 1. So now this is the final form of the function that we can actually use to answer the problem. Because notice that once we put a negative infinity into the numerator of x, we would get, so we have negative infinity inside the numerator divided by negative square root 2 subtract 1. Because we have two negatives, that's going to equal a positive, right? So, because we're dealing with an infinity, it's going to be, the answer is going to be equal to positive infinity. So as x is approaching negative infinity in this particular function here, it's going to actually approach positive infinity as the associated y value. So I hope this may have helped you, perhaps not confused you. If you have any questions, please comment below and I will do my best to answer them. I hope you're having a fantastic day.